Hi, my name is Charlie. You can also call me the Guitar Boy. Today, we are going to be talking about more theorems in psychogeometry. You know, in our last video, we treated some theorems in psychogeometry. In addition to the we are just going to be taking 2 theorems today. In addition to the previous one we took, I think that one will be okay for us to tackle a lot of questions from WAEC, JAMB, NECO, and some other exams. So today we are going to answer some questions from WAEC question this particular year 2024. This previous WAEC that just passed will answer some questions on the psychogeometry today. But before then, let's go to these 2 theorems first. So the first one is a tangent is perpendicular to the radius at the point of contact. A tangent is perpendicular to radius at the point of contact. A tangent is perpendicular to radius at the point of contact. This theorem is saying, let's say we have a cycle and we have a tangent like this. It's perpendicular no matter how you, in as much you draw the radius from the center to the tangent, just know that it is perpendicular. You know the meaning of perpendicular. It means this angle here between the tangent and the radius is 90 degrees. That's the meaning of perpendicular. When I say it is perpendicular, I mean this radius, the angle between the radius and the tangent is perpendicular. It is as simple as that. So that is what this theorem is saying. It's saying that when you draw the radius of a cycle to meet a tangent at the point of contact, just know that the angle you will get is a perpendicular angle. So let's move to the next theorem. The next theorem says that the angle between a tangent to a cycle and a chord through the point of contact is equal to the angle in the alternate segment. Look at what this one means. Let's say you have a cycle. And you have let me say a tangent. You have a tangent and you draw a chord to this is a chord, and you have another chord here, and you have another chord here. What this particular theorem is saying that this angle, this is an alternate segment. This is a segment, alternate segment. So this theorem is saying this angle is equal to this angle when you have something like this. Another way you can draw this is like this. When you have something like this, this one means that if everything here is A, just know that this place is A, which means if we have 30 here, this place is also what? 30. This is a theorem you must put in your head. Now, let's say this is a tangent. Another way you can draw it, and you draw a line from here. It does not matter where you draw it from. You draw a chord from here, and you draw another one from here. You draw another one from here. You draw another one from here. So what you now have here is that this angle is the same thing as what? This angle. Which means if you have 30 here, just to know that you also have 30 degree here. This is what this particular theorem is talking about. This is the angle in the alternate segment. This is the angle that is equal to it. So when you have something like this, you just know that this angle and this angle are equal. That is what you are required of in this particular theorem. When you have something like this, you see a segment like this, and you this angle and this angle, just know that they are equal. Once you have that information, you will be able to solve most problems in geometry. So we are going to stop here. There are other theorems you can also learn besides these theorems, but I don't think time will permit us to touch all of these theorems. The ones we have done are enough for we to solve most questions in geometry. Basically, they are enough for us to solve most questions in any of these exams. Okay, let's solve one question. Let's start solving questions on cycle geometry. So let's solve this one we have on the board. Okay, this one is saying, well, from this figure we have here, they ask us to look for OH, line OH. How do you recognize what they mean? When you see this line here and line here, this means line OH, or you see you might have it like this, line OH. Okay, they ask us to look for what? Line OH. Now where is line OH? Here to here is line OH. Now checking, if you check this, what you have here, this place is perpendicular. You already know from one of the theorems that says that when you draw a line to meet a chord at the midpoint, you know that this one is perpendicular. Now they ask you to look for this line. You know that for you to look for this line, you need to know from here to here and from here to here, because you know that this is a perpendicular shape. If you know from here to here, because of this sign here, this perpendicular angle here, we state because of this perpendicular angle here, you already know from the theorems in the past that here to here is 20, here to here is 20, because everything from here to here is 40. Remember, the theory says that when you draw a line from the midpoint to meet at the center of a chord, you know that the angle between the chord and the radius will be what? Perpendicular, in as much it meets at the center. So because how do I know that here to here is half and here to here is half? Because of this place. Because this place is already perpendicular, it shows me that this line meet at the center. Because this place is perpendicular from the theory, it shows me that this line meet this one at the center. So with that, I can modify this figure we have here. I can clean this part, or maybe because this is objective, I can clean this part and put 20 here and put 20 centimeter here. So when I do that, I will now use Pythagoras theorem. So what do? I will say, I will say OH square equal to, this one is line OA square minus line AH square, which is equal to what? 25 square minus 20 square. So this 25 square will give you 625. This one will be 625. 20 square will give you 400. 400. So 625 minus 400 give you 225. When you take the square root of both sides, this one cancel this one. You have OH equal to what? 15 centimeter. So which means OH, that's distance from here to here, is equal to what? 15 centimeter. So this will be the end of this video. And if you are here in Edo State and you want physical classes, we are close to Belesima Junction. You can come and join us at Okawa. We are very much close to Belesima Junction for physical classes. Edo State, Saple Road, bypass, close to Belesima Junction. Come and join us for physical classes. Thank you. Bye.